Okay, now in this question we're being asked to look at boiling points, and obviously we're going to be talking about bonding. And in scholarship, one of the things to keep in mind obviously is it's asking a little bit more of you, so you should know the basics that as we get larger molecules we're going to have stronger temporary dipole-dipole bonding that goes on, those dispersion forces. We should recognize hydrogen bonding when it's there and when it isn't. We should also recognize that if a molecule is shaped in such a way where it cannot get close to another molecule, then the forces of attraction will be weaker. So if we're looking at an organic chemistry, linear straight chain molecules going to usually bond and get closer together than, say, one that's got branches coming off it. So the information that we're given usually will give us a good idea of what's going on. And in this question, when we look at these, if we look at the first one here, a lot of the molar masses are fairly similar here. This one for diethyl methylamine, which is very similar to ethyl dimethylamine. There is a slight difference in the molar mass. The kind of bonding that can go on here is fairly similar. We've got no ability to hydrogen bond because this nitrogen isn't bonded to a hydrogen, so there's it's a tertiary amine, so that can't actually happen. So the difference in boiling point here is really more due to just the fact that we've got a higher molar mass, and that's why it's different there. Now when we look at 2-dimethylpropylamine and 1-butylamine, obviously we see a huge leap in the boiling point, even though the masses are pretty much exactly the same. So what's the difference here? Now they look very similar, and they both have the ability to hydrogen bond. They both have the same molar mass, but if we look at this one, it's got 3 methyl groups with the amine group, and there's obviously going to be a lot more branching going on in this one. That's made it a bit of a mess to see, but anyway, and this one will have less branching. So the fact that this can pack closer together means that that's going to have a stronger force of attraction, and it's going to have a higher boiling point. It'll take more energy. Okay. Now if we look at this amine versus 2 and 3, even though obviously there's a significant difference here, the main difference is this one cannot hydrogen bond and these both can. So that's a fact that you should mention there as well. Okay. And so obviously the one with the highest boiling point is the one that is not branched to the same degree, and in fact there's no branching there at all, sorry, and also has the ability to hydrogen bond, whereas this one does not have the ability to hydrogen bond, and even though it's got a higher mass, it's going to have a lower boiling point. Okay, so that's that one answered.